Hello, today we'll be discussing the paper Vascular Endothelial Function Masks Increased Sympathetic Vasopressor Activity in Rats with Metabolic Syndrome by Batul et al. Before we go into too many details about the contents of the paper, we must first go over a little bit of background information. So what is metabolic syndrome? Metabolic syndrome is characterized by the accumulation of a number of different metabolic dysregulations. These dysregulations could be anything from obesity to hyperglycemia to even insulin resistance. So as these metabolic dysregulations accumulate, they put the individual at an increased risk for a number of different conditions, these being cardiovascular disease, type 2 diabetes, and hypertension, which we'll be focusing on today. Another topic that will be heavily discussed in this paper is the sympathetic nervous system. So the sympathetic nervous system is commonly referred to as our fight or flight system. This is because it is characterized by an increase in activity of a number of different organ systems throughout the body. Specifically, it serves as a major vasoconstrictor system. What that means is it's going to increase blood pressure by constricting the blood vessels. It does this by targeting alpha-1 adrenergic receptors, which are found in the endothelial lining of blood vessels. It releases epinephrine and norepinephrine as hormones, which are able to target these alpha-1 receptors in order to cause the constriction of the blood vessels. So it is important to understand how metabolic syndrome and the sympathetic nervous system are connected together. So if we have a patient that is exhibiting the conditions that are associated with metabolic syndrome, it is often accompanied by an increase in the sympathetic nervous system, which shows how these two conditions are linked. So the metabolic syndrome conditions like insulin resistance and obesity are both positive modulators for the sympathetic nervous system. And then since the sympathetic nervous system acts as a vasoconstrictor and the conditions associated with metabolic syndrome often lead to hypertension, these two conditions can act together synergistically in order to raise blood pressure. Since both metabolic syndrome and the sympathetic nervous system lead to an increase in blood pressure, this can be particularly dangerous if the body is unable to blunt their combined effects in order to keep the blood pressure at a normal level. So now that we understand a little bit how metabolic syndrome and the sympathetic nervous system can work together in order to increase blood pressure, it is important to realize that the body does have systems in place in order to ensure that the blood pressure does not reach too high of a level. One of these is the nitric oxide system. So nitric oxide is a gas that can serve as a vasodilator for blood vessels, which means that it just relaxes the smooth muscles that are found in the walls of the blood vessels. So the way that nitric oxide is produced is by an enzyme called endothelial nitric oxide synthase. So this enzyme is found in the walls of the blood vessels and the endothelial tissue, and it is here that nitric oxide is produced and released. The way this is done is these endothelial cells are actually monitoring the blood pressure, and then according to how high or how low the blood pressure is, it can then release this nitric oxide, which is being produced by the enzyme endothelial nitric oxide synthase, in order to help balance the blood pressure. So now to get into a little bit of what the actual experiments that were done by the researchers. So what they did was they used rats as their model organism. And the rats that they used were fed a high-fat and high-sucrose diet. This diet was supposed to induce metabolic syndrome in a similar manner that humans acquire this disease by eating a poor diet. So these rats were put through a number of tests. One thing that was done with the rats was the aortas were removed in order to create aortic rings, which were just a sample of the aorta. These aortic rings were used in order to measure the vasocontractile capacity of the rats. These aortic rings were treated with phenylephrine, which is just an agonist of epinephrine and norepinephrine, so it's supposed to simulate an increase in the activity of the sympathetic nervous system. So what they did was they took aortic rings, which were in normal condition, so this served as the control group, and then they also took aortic rings in which the endothelial layer of tissue was removed. Just a reminder that endothelial layer is what is responsible for releasing nitric oxide, which serves as the vasodilator. So they sort of wanted to see how this phenylephrine, which serves as a vasocontractor, would react without being able to release the nitric oxide, which serves as a vasodilator. Finally, they looked at the blood pressure in rats that had been treated with L-NAME. L-name is an inhibitor of the enzyme endothelial nitric oxide synthase. With this enzyme knocked out, the rat would be unable to release nitric oxide into the blood vessels, which means that it will not be able to have that vasodilation effect, meaning that it will be unable to lower its blood pressure like you would see in a normal rat. So now looking at the actual data from the experiments, this first figure is going to show the effect of an increase in the sympathetic nervous system. So on the x-axis, we see we have both our control rat group, as well as our rats that were fed that high-fat and high-sucrose diet, which induced metabolic syndrome. So as you can see, the rats that have this induced metabolic syndrome have an increased plasma level of both epinephrine and norepinephrine, which are the hormones that are released by the sympathetic nervous system, which causes vasocontraction or an increase in blood pressure. The second figure, again, we see both the control rats as well as the rats with induced metabolic syndrome. And what this graph is looking at is also showing these aortic rings. And some of the aortic rings with the minus is showing that they have removed the endothelial cells, and the plus means that the endothelial cells are still intact. As you can see, there is a higher rate of tension in the walls of the blood vessels when the endothelial cells have been removed. This is because these endothelial cells are responsible for releasing nitric oxide through the endothelial nitric oxide synthase enzyme, and without these endothelial cells present, it is unable to release this nitric oxide, which serves as a vasodilator, decreasing the blood pressure in the walls of the aorta. So looking at our final figure, we are again looking at the control rats as well as the rats with the induced metabolic syndrome. Another layer we are looking at here is rats treated with this L-name substance. What this substance does is it interferes with the endothelial nitric oxide synthase enzyme, which is responsible for producing and releasing nitric oxide into the blood vessels. On the y-axis, we're looking at the average blood pressure of the rats. When comparing the two groups with no treatment, we see that there is no significant difference between the average blood pressures. This is because the blood pressure of the rat with metabolic syndrome is being lowered back towards a normal blood pressure by the nitric oxide being produced by the endothelial nitric oxide synthase. However, when this important enzyme is interfered with due to the L-name, we see that the blood pressure is no longer able to be lowered. This is why we see a higher average blood pressure for the metabolic syndrome rats that were treated with the inhibitor, because there is no nitric oxide being produced to mask the vasoconstriction experienced by this metabolic syndrome rat. Overall, the researchers came to some important conclusions about the relationship between metabolic syndrome and the sympathetic nervous system. So what they concluded was that rats that experience metabolic syndrome also experience an increased activity in the sympathetic nervous system. However, it is important to note that they saw that this increase in activity in the sympathetic nervous system did not ultimately have an effect on blood pressure. This is because the endothelial nitric oxide synthase system is able to mask the vasoconstrictor activity that is seen with an increase in activity of the sympathetic nervous system. This research reaffirms the critical nature of this nitric oxide system as an important system used to regulate blood pressure through its vasodilation capabilities. So some questions to think about in regards to this research paper are: what types of blood pressure medications exist that specifically work to mask the vasoconstrictor activity of the sympathetic nervous system, and how do these medications work? Another question is, what properties of nitric oxide make it such a good signaling molecule, and particularly in this pathway?